Hello folks, this is Jay Ghoshal, and in this video we are going to cover error handling. One of the things as developers we are faced with is making sure that we have got good error handling coverage throughout our program. So what we typically do is we set up try catch blocks. Some places it is required, say if you're doing IO and things, and other places it's optional. So we will try to be conscientious and we will write adequate error handling logic like try catch blocks. But if you are supposing a project lead or you're in charge of this project, you want to ensure that I have a good error handling across the board, right? There is no situation where error handling is missing, and that can lead to unhandled exceptions. So to get around all that, one of the uh, lovely things that Spring Boot provides is an annotation called add controller advice. Now what this does is it is basically ensures that any exception that is thrown anywhere in your program, and if it is unhandled, it comes over here to this particular location and you can centrally handle it. So if in your project you have at least one class in which you put this add controller advice, you are guaranteed that errors thrown anywhere will be routed here, and then you can centrally handle this. Okay. So I have the code already written out. It's a lot of code, so it will take a lot of time typing. So what I'll do is I will go and I will walk through the code, and you guys can follow along. So the first thing we did was we created a new class, okay, called error handling controller. You can call it whatever you want, and at the top of it, put this add controller advice. Okay. Now once you do that, you're pretty much guaranteed errors will be routed here. Inside there, I have some exception handler tags, and what these are for is when stuff will show up in this class, I want to have say different treatment for different kinds of errors. So if you have say a SQL exception, if you have null pointer exception, you have all kinds of different things, and you want to handle them separately and have different treatment, different kinds of messages, different logging things. You could potentially do that by creating similar classes and essentially dividing up how you do the thing here. Now what we are building here is we are essentially enhancing the service we had written, right? And that is a simple service that basically returns REST responses. And one of the things we want to do here is we want to essentially send a simple response back to the client that is consuming our API. And we want to do is we want to write out detailed error messages to our uh, to our logging system. Okay. So I'll come in a second what these things are, but let me go around and show some of the other things that I've created here. So I have created here a custom exception class in which is basically a component, and it extends exception. Inside that exception is a code and a message. Now code and messages are part of the exception object. So essentially I'm overriding the code and overriding the message. I probably should put add override tags here, but for now basically that's what's going on. And I have getters and setters. Okay. So if I delete this thing, that's my class, and I can right click, go to source, generate getters and setters, and I got my class, right? So depending on your need, what you want to send back to the client, you would basically uh, create custom classes, and all they need to do is extend exception. The next thing is we are going to send back JSON, right? So it's a REST service. People are going to call, and if there's an error message, issue, we want to send back a JSON response that they should be able to handle. So I have created an exception response, I'm calling it, and again I'm going to give out a code and a description. It can be a message basically, and you could, or I think for consistency you can perhaps call it message, and then again I have getter setters. So essentially we're going to fill up this response and then return it. Then I have written a class called exception thrower to actually simulate exception. Okay, so what I'm doing here is I am throwing some general exception. This is basically a method. I create a new exception, I throw it, and the other one I'm creating a custom exception. So basically I am instantiating one of these custom exception objects. I set the code and the message using the setter getter setters, and I throw it. Again, custom exception is extended from is extended from exception, hence throw and all that is available to us. Let me try one thing here which I have not tried, but let's give it a shot and see what happens. Public, I will say throw null pointer. Okay, what is this? All right, so in here, let's say I will say string string, I don't know, and then I say should be a null to begin with. Wondering what is the good way to do this. Okay, so I want to do is okay. So I'm guessing, I hope this will bomb. Okay, let's see what happens. Okay, so anyway, so we have a couple of methods here. There two are elegant, and hopefully this we can simulate some sort of crazy error. Then in our controller, if you remember from the past sessions, we basically have a controller, and in the controller we essentially send an object. We take the request body, we map it to an internal object, and then we return that object back. So if you are not familiar with this, you can see one of the previous lessons on the REST controller, and we have covered it in detail. All right, so let's go ahead and start up the service. And if I go to Postman, so whatever I sent comes back. Okay. So if I go back to my code here, essentially whatever is coming in is going, and if I look at the console, I'm also writing it out to the console through here. Now what I'm going to do is I'm going to simulate some exceptions. And we threw the general exception, and it's coming back here. Okay, and I will go through the details on where all this thing is coming from. If I stop it, and we are getting the other error, right? So depending on which one we are throwing, we are getting the different error back. And to test it, let's see what happens. uh, Moment of truth. I know when I don't need it, I can throw or get all kinds of let's see if this thing will do anything. So it doesn't look like it is bombing. Okay, so never mind. But basically, if you got actually now that string name, hmm, hmm, okay. So we basically have, we can see here, we are not trapping this, handling this at all. We basically are having a null divide by zero error, and our central error handler is catching it. Okay. So it's pretty slick, right? So this is what would be a typical unhandled exception. All right. So looking here, let's go and look at this in a little bit more detail. So essentially, I have got this exception handler for exception.class, in which I have essentially, I'm going to return a JSON from here. So it's very similar to your this guy. Okay. Public response entity, blah, 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 right? It is very similar. It says response entity exception response. Exception response is our object that we want to send back, right? So this guy, we want to send this guy back. Okay, so that's the same thing. General exception, and it takes an input of exception object and it throws exception. And exception response, we initialize. The set code is, we are basically using HTTP status internal server error. So if you look here, we are getting in the status back an internal error. So if the client is having error handling, it is going to see this error condition and handle it. So it is not that you are sending 500 here and you're returning a 200, which is like a normal, it's okay sort of thing back. You are actually sending a fatal error back, and that is going to be tracked by the calling client. So that's what we are doing. So once we get that, we are sending an internal error. Now there's many choices here, so you can pick and choose what you want to send. In the description, we are putting in the description. Again, here you may not want to do this. You may want to give some meaningful messages, right? Age calculation wrong, salary calculation wrong, whatever it is. You don't want to perhaps stream out this error handling, this raw data, because here it is okay. It says divide by zero, but it means nothing to a client, right? What does divide by zero mean, right? You really want to say, sorry, or blah 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 was not possible, right? We could not save data or whatever, or something elegant, right? And in your internal logs, you would pretty much write out stuff like this. So you would essentially, instead of saying setting the description as a get message, you would basically set here something else, but you would write out the E. So we would know all the details. And essentially you return a new response entity with the HTTP status of internal error. This is what's leading to that 500 in the postman, and you're setting this, and inside there the code is this and the message is this. Now your receiving program, if they also have are extending errors or sorry exceptions, they could then route your 500 in there and route this, and they could do their different things, right? So that's the general idea. On the other side here, we pretty much we are getting that first name not valid or something like that, right? So let's take a look at it. So this is like a data validation, right? So if you have essentially somewhere deep in your program, you have something that says validate data or something, you would essentially do all kinds of validations and put out these messages and throw a custom exception. You could perhaps call it a validation exception, and then that would be sent out. And if you notice here, we are sending out 400, we are not sending 500. So it is suggesting that there is some issue with malformed data, or information that has come to us is inaccurate. Again, there are several statuses available. You can pick and choose what is best suited for you. So this is in short how to do customer handling. Just to recap, you build a class. In the class you put this controller advice. Inside there, if to begin with you don't need this, you can just build this guy, and in that you also don't need all this code. Okay, all you need is perhaps the system.out.println line, so that you know what is going on, and it would all errors would automatically get routed here. It would write out and not bomb because it's now caught, and you could then do the analysis, and your application is secure. If you want to give more meat to it, you want to perhaps, and it's probably a good idea to provide, if somebody calls API and nothing comes back, it doesn't mean anything, right? So at the very least, you need to throw back some sort of error code so they can understand that, okay, there was an error, and provide some meaningful message. And to do that, you would basically, you are essentially creating a new object in which you're populating with those two elements, throwing the error code and returning the object. If you want to be more sophisticated and you have different kinds of errors, you can have one handler for SQL errors, you can have one handle for interface errors, one maybe for file errors, all kinds of things. You could build several classes like this, and then put custom logic in there, put custom descriptions, and then provide different kinds of response codes, and then people would essentially know what is happening. Okay, one good thing to do is, you definitely want to give some tangible information back. There's nothing more frustrating for a developer who's consuming your API to get saying that something happened and that's it blew. There's nothing more frustrating than that. So you want to make sure that you provide some meaningful messages and meaningful error code, so whoever is consuming your API developing software can actually understand what's going on, and somewhat what's going on and why the thing is failing. So that's it for now. Hope you enjoyed the video. In my opinion, at least, this is a must. If you're creating any kind of Spring Boot application, you must have a class like this. Even if you have rock solid error handling, just create one with a basic exception class and maybe just a little logging thing. But this is a must, because this is the one thing that guarantees that you have got error handling end to end in your application. All right, so that's it for this video, and hope you liked it. If you like the video, please feel free to hit a like, and I'm going to post the source code in the description section. Thank you for watching, and we'll see you in the next video.